Now, the second reflection on the experiment is threshold wavelength. First, what does threshold mean? Threshold is the step that you have in front of your house. So at the door, at the entry of your house or the entrance of your house, there is this step. When you step inside it, you are inside the house. When you step out, you're outside the house. It is like a boundary between being in and being out. Threshold wavelength is the same thing, but it controls the emission of an electron or not. 4. It is the maximum wavelength of radiation capable of extracting electrons from the surface of a metal. We have seen it, for example, for calcium. 427 nanometers is a threshold. Above this value, nothing happens. Below this value, photoelectric emission takes place. So this is what we need to memorize. When lambda is less than lambda threshold, photoelectric effect is observed. Let's go solve an application about this. A radiation of wavelength 300 nanometers illuminates the surface of a metal having a threshold wavelength of 0.2 micrometer. So first, define threshold. If I go to 3 first. What is threshold wavelength of material? It is the value of wavelength beyond which no photoelectric effect will take place. I made this a bit hard. It is the maximum value of wavelength producing photoelectric effect. Or, my pre-installed answer is the maximum wavelength of the radiation capable of extracting electrons from the surface of metal. Instead of saying photoelectric effect, I explained it. I have here another choice. It's the maximum wavelength of the radiation capable of producing photoelectric effect. Go back to 1. Indicate the type of this electromagnetic radiation. Well, you're not supposed to memorize that, but 300 nanometer is less than 400 nanometers, which is a boundary of visible light, so this is invisible, or it's an ultraviolet radiation. Are there any electrons emitted from the metal? Well, the threshold is 0.2. Lambda is 300 nanometers. Converting nanometer to micrometer, we divide by 1000, so we get 0.3 micrometer. 0.3 is greater than lambda s, which is 0.2, implies no photo emission. If I go up to this page, remember, when lambda is less than lambda threshold, we will have photoelectric emission. If it's greater, nothing's gonna happen, and here it was greater. Threshold frequency. What does threshold frequency mean? Again, it's also a boundary, but it is a boundary inverse to the boundary set by wavelength. When it's the minimum frequency capable of extracting electrons from the surface of a metal. When frequency is greater than us, photoelectric effect is observed. So by now we have 2 vocabularies that we have to know to add to our bucket. Okay, the work function of a metal. Now this will be the last definition or vocabulary we're gonna set for this chapter. Okay, it's a bit long, but it's not that hard. Before we start with the work function of a metal, we need to review things about, I told you once about what Max Planck suggested. Max Planck suggested that a photon is 1 unit of light. He defined that unit as 1 unit of carrying 1 unit of energy. So the particle or the part of light carrying 1 unit of energy, not the whole energy, not continuous energy, is called a photon. The energy given for 1 photon is E equals h times nu. Nu is the frequency. Nu, and nu, we read it nu, it's a Greek letter. It represents the frequency. I don't know why they don't use F. However, it's found as nu, so we just keep it. Okay? And h is known as Planck's constant, and we just need to know the value. It will always be given, don't worry about it. 6.6 times 10 to the minus 34. You notice that 10 minus 34 is a very low value. So when we deal with photoelectric effect, expect very low numbers to be observed. Now, for a photon to extract an electron, it should possess a certain minimal energy. This energy is defined as the work function of the metal. Logically speaking, we talked about frequency and wavelength. In order to extract an electron from a photon, there is a minimal energy we have to give to the electron or to the atom. You all know from chemistry that electrons are bounded to the atom by electric force. How can I overcome this force? I need to give it some energy. And that energy is the E equals h nu. Let me just circle that. This minimal energy that is required to produce the photo emission is known as what? Okay, is known as the work function. Now, the value nu zero, this is something I would like to highlight. So when we say nu zero equals W0 equals h times nu, which is the frequency threshold, or hc over lambda threshold, this value is called the work function and it characterizes the metal. This is something to memorize. Third, when we deal with these values, I told you here the number is very small, 10 minus 34. So we expect numbers to be very low. That's why we have to set a new value for energy. On the atomic scale, energies are small, order of 10 minus 19 joules. Thus, it's convenient to use a unit called electron volt. We might have discussed this in grade 11. Okay? 1 electron volt is 1.6 times 10 minus 19 joules. Once again, this will always be given. So you notice that the electron volt is a very low value energy. It's 10 minus 19. Okay? So this is what I need to know so far. One more thing. As a conclusion, what can we say? If energy of the photon is greater than the threshold energy or the work function, or equal to it, yes, a photon will be extracted and photoelectric effect is observed. Now, what are some work functions of some metals? Just have an idea about this. Gold 5.1 electron volt, uranium 3.6, nickel, magnesium, mercury. We should have added zinc here to compare to what we have seen before. Anyway, these are the values in electron volt of some metals. Each metal has its own work function. Great. So far we've done a lot of things and I think you have a lot of work to do now. Here we have an application. The work or extraction function of tungsten is 4.5 electron volt. Is there any photoelectric emission if it's eliminated by ultraviolet radiation of wavelength 0.25? To answer that, we can either go to threshold wavelength or we can go to the work function and the energy of the photon. So what I can do here is find the energy given by this lambda using hc over lambda. I have written this with my hand. Okay? We calculate the energy given by the photon, hc over lambda. H is given, c is given, and lambda is given. Then that number is to be compared to 4.5. If it's more, then yes, photo emission happens. If it's less, no, nothing happens. So E equals, and excuse the handwriting, E equals hc over lambda, calculate that, 7.92 10 minus 19 joules, a low number, which is reasonable. Now divide by 1.6 to convert. Pay attention to have this within brackets when you divide, yes? So E gamma is 4.95. Now it's easy. 4.95 is greater than 4.5, so yes, photoelectric emission is gonna be observed. Now I would like to move to another application, and please try to solve it for next time because it has like everything we're gonna need as vocab. Consider 3 photocells whose cathodes are covered by cesium, potassium, and lithium respectively. The extraction energies are also given in electron volt over here. Define work function. Then each plate is illuminated separately by a radiation of wavelength 0.6. Calculate the energy of this photon or this radiation. Is photoelectric effect obtained in any of these plates? And you have to explain. So it's straightforward, doesn't have a lot of things to think about. However, I would like you to solve it to practice if you have grasped all the concepts for this part. Now, before we end up, I have like a quick summary of everything we've seen so far. This is the foundation and the basic part of this chapter. Next time we're gonna start from here to build up the photoelectric effect and how was Albert Einstein able to summarize it, or anything you wanna do. Okay, but this is the essential part that you need. Maybe the most important thing here is, when is photoelectric effect observed? When the energy is greater than the threshold, frequency greater than threshold frequency, and wavelength is less than the threshold. Definitions are also important over here. Okay? Now, thank you for your time. It's been a long part, but as I said before, it's essential for the upcoming and the remaining section of this chapter. Please solve these, and until next time, stay safe.